In this lecture, we're going to talk about bitwise operators in C. This is part 1 of the bitwise operators. What is the outline of this lecture? Here we are going to introduce the concept of bitwise operators. What are bitwise operators? Then we are going to talk about bitwise OR and NOT operators. Then we will have a discussion about the difference between bitwise and logical operators, as this is one of the most confusing topics of all time. Let's try to understand what are bitwise operators. As name suggests, it does bitwise manipulation. Now, what is the meaning of bitwise manipulation? We will talk about this concept later in this lecture. Right now, we will focus on different types of bitwise operators available in C language. The first bitwise operator in this list is Bitwise AND Operator. Second operator is Bitwise OR Operator. Third operator in this list is Bitwise NOT Operator. Then we have a left shift operator. Then we have a right shift operator. And finally, we have Bitwise XOR Operator. Now let's try to understand what is Bitwise AND Operator. It takes 2 bits at a time and perform AND operation. AND is a binary operator. First of all, please note down this point. It is a binary operator, which means it requires 2 operands. It takes 2 numbers and perform bitwise AND. Result of AND is 1 when both bits are 1. And this is also one important point to note. We know this thing already, that the result of AND is 1 when both bits are 1. Let's take one example in which we would be able to understand how bitwise AND operator takes 2 numbers and perform AND operation bit by bit. Here suppose we have 2 numbers 7 and 4. This is the binary representation of 7 and this is the binary representation of 4. What bitwise AND operator will do is that it takes 2 bits at a time and perform AND operation. 1 and 0 is 0, 1 and 0 is 0, 1 and 1 is 1, 0 and 0 is 0. We know this thing result of AND is 1 when both bits are 1. When both bits are 1, then the result is 1. For the sake of reference, here is the truth table for the AND operation. Only when both bits are 1, then the result is 1. Otherwise, the result is simply 0. As you can see in this example as well. Therefore, final result is 0, 1, 0, 0, which is equivalent to 4 in decimal. Therefore, we can say that 7 bitwise AND with 4 is equals to 4, right? Okay. Let's try to understand the concept of bitwise OR operator as well. It takes 2 bits at a time and perform OR operation. OR is a binary operator. It takes 2 numbers and perform bitwise OR. Let's consider one example. Here in this example, what bitwise OR operator will do? Result of OR is 0 when both bits are 0. Therefore, when both bits are 0, then only the result is 0. Otherwise, the result is 1. Here is the truth table available for the OR operator for the sake of reference. 0, 1, 1, 1 is equivalent to 7 in decimal. Therefore, the final result of bitwise OR operator between 7 and 4 is equals to 7. Okay? Now let's try to understand the concept of bitwise NOT operator. NOT is a unary operator. That means it requires just one operand. Its job is to complement each bit one by one. As it takes only one operand, therefore, its job is to complement each bit of that number one by one. Result of NOT is 0 when bit is 1 and 1 when bit is 0. Simple. Complement means that 1 becomes 0 and 0 becomes 1. Now let's consider one example of bitwise NOT operator. Here in this example, I'm going to apply bitwise NOT operator on this number. Binary representation of this number is 0, 1, 1, 1. 1 becomes 0, this one becomes 0, this one also becomes 0, and finally this 0 becomes 1, according to the NOT operation. Therefore, the final output is 1, 0, 0, 0, which is equivalent to 8 in decimal. NOT of 7 is therefore equals to 8. Now let's try to consider the difference between bitwise and logical operators in general. I'm going to provide you one example which is enough to understand the difference between bitwise and logical operators. In this example, we will talk about the difference between Bitwise AND operator and logical AND operator, and the same concept is applicable to the other operators as well. Here I have declared two variables x and y and assigned them value 1 and 2 respectively. Binary representation of 1 is 00000001 in 8 bits form. Because the data type is character and it can store up to 8 bits of information, therefore 1 is represented in 8 bits form like this. Similarly, 2 is represented as 00000010. Here I have provided two if constructs. This printf function belongs to this if construct and this printf function belongs to this if construct. When the condition inside this if construct satisfies, then this printf function will be called, and when the condition inside this if construct gets satisfied, then this printf function will be called. Now please don't bother about the curly braces. When we write single statement immediately after the if construct, then that statement will automatically be a part of that if construct only. Therefore, this printf function is part of this if construct and this printf function is part of this if construct. There is no need to put curly braces here and here. Now let's try to understand the difference between this bitwise AND operator and logical AND operator. When we perform bitwise AND between these two numbers, that is 1 and 2, what would be the result? 1 bitwise AND 2 is equals to 0. Isn't that so? 0 simply means false, which simply means that the condition inside this if construct is not satisfied, therefore this printf function will not get evaluated. On the other hand, here I have provided a logical AND operator. Now what is the result of this logical AND operation? 1 is treated as true and 2 is also treated as true, as value other than 0 is treated as a true value. We know this thing already, that true and true is equals to true, which is equals to 1. Therefore condition inside this if construct will get satisfied and therefore this printf function will be called, and the final output is result of x logical and y is 1. Right? Now this is not very difficult to understand the difference between bitwise AND operator and logical AND operator. Okay friends, this is it for now. Thank you for watching this lecture.